Hey, our space science class, it's Hugh here. This is just the fusion reaction assignment. I'm just going to go through some of the main things you need to know. And excuse me, I'm just going to grab a periodic table. I think I need that. All right. So the first part of this is to understand a little bit about how matter works. So this is just a review of the atomic theory. There are three particles: a proton, neutron, and electron. So little p, little n, little e. Protons always carry a positive charge, so its charge is one of its two most important properties. It's electrical charge. So protons are positive, neutrons are neutral, and electrons are negative. The other most important property is the relative mass, or how heavy they are. In terms of the size, all you need to know is that the protons and the neutrons are about the same. They're about what's called one atomic mass unit. So if I was representing them, that might be like that. That's the proton, and like that. That's the neutron. But the electron is just a itty-bitty thing, just tiny, right? So it's much smaller in mass, although it does carry the full same charge as the proton. It's just opposite. Okay? Also remember, of course, opposite charges attract. So protons and neutrons attract each other. Protons and electrons attract each other. Neutrons don't. All right, so elements do come in varieties, and they're called isotopes. The element type is determined by the number of protons. The smallest of all elements is hydrogen. It's here in the top left of the periodic table. It's atomic number 1, which means it always has one proton. There are different flavors or versions of hydrogen, and they're called isotopes. But to be hydrogen, to have an H, you have to have one proton. To be helium, over here, you must have two protons, and so on. So carbon has 6 protons, so sulfur has 16, and so on. That is the atomic number. It's always a number of protons. So hydrogen, being the smallest one, has got one proton, and the protonium is your normal, usual hydrogen. It's simply one proton, and because it has one proton, it has one electron. The next one's called deuterium. If you see the difference, one proton, one electron, but this one has a neutron. And then tritium simply has 2 neutrons. So you can have varying numbers of neutrons in the nucleus to get different forms of the same atom. They're still hydrogen. When we look at the numbers that we associate with this, the symbol here for hydrogen, the lower number always has the number of protons. So that's your atomic number. The upper number is called the mass number. And it's always the number of protons plus the number of neutrons. So for example, a 1 here means there's 0 neutrons. For this one, a 1 here means 1 proton, 2 means you've got 1 proton and 1 neutron. And then here, 1 proton and 2 neutrons. And that's how you represent the symbols of the different isotopes. Okay? So here's a question. Which element are we looking at here? There are 2 protons, there are 2 neutrons, and then 2 electrons. So it's really 2, 2, and 2. 2 protons, 2 neutrons, 2 electrons. And quite often we'll put the symbols, the charge symbols there. Okay. For the symbol of the element, you don't need to worry about anything except the number of protons. It has 2. According to the periodic table, it's a helium, atomic number 2. Since it's helium, its atomic number must be 2. The mass number is the total number of neutrons and protons in the nucleus, and that's 4. So this would be symbolized as 4 to helium, or helium-4, and then of course it's this one, that's the right answer. Okay. Let's put an X there. Put a Y right next to the symbol of an isotope that has 1 more neutron. So that would be helium. It has to have 2. An extra neutron would be 5. So it's that one there. Let's take a look at some of these nuclear equations. So first of all, we have 2 hydrogens, and they are not the regular ones. These are deuteriums. 2 deuteriums coming together, and the result is now 2 hydrogens, but what's happened is that they're not deuteriums anymore. This one's a tritium and this is one a protonium. So really what's happened is that if you think about it, here we had a proton and a neutron plus a proton and a neutron, and this is a nuclear reaction where one of the neutrons shifts over. So this one has a proton and two neutrons, and this is just a proton. In this one, it's a bit more interesting. Two protoniums. This one has just one proton each. Two atoms with one proton each. This one has a proton, but because it's got mass number 2, it's got a neutron as well. So really what's happened is that these two have hit each other, and the proton has turned into a neutron. How is that possible? Well, for a proton with a positive charge to become a neutron with zero charge, it must have released a positive particle. And this is symbolized by this character here. So a proton can turn into a neutron when it releases this particle, and this is called a positron. Positrons are famous in science fiction, but they are real things. This is a positive electron. So remember from the first page, we identified an electron as one of the fundamental particles, but it's always negative. This one's a positive electron. Same mass, positive charge. And this is a part of what's called antimatter. There is a set of particles that would all be the exact same as the world that we live in, the universe we live in, except that the charges are reversed. Because if you think about it, opposite charges attract. The model for the atomic model here works because negative attracts positive, and that holds the atoms together. However, it would not be impossible to imagine a negative proton and a positive electron, and everything would work just as well. That's what antimatter is. Antimatter is the same kind of matter as we have, but with the opposite. So here, proton, neutron, and electron, that's regular matter. Antimatter would be P with a negative and E with a positive. And interestingly, the neutron is exactly the same. Neutrons would be present in matter and antimatter. Okay. One thing you might notice about these equations and the thing here is that the total numbers on the top on both sides have to equal. For example, 2 times 4, that's 4 on the top on the left, 3 and 1 is 4. 2 ones is 2, 1 and 1 is 2. In this one, 2 and 2, so 2 on the left, 2 plus 0, 2. 2 on the right, and 1's there and 1's there. So that's the pattern that you have to look for. Okay. So I'm just going to take a second to analyze one of these equations for you. Let's take a look at A. A hydrogen, one proton, one neutron, so that's a deuterium, and another deuterium come together. They make a helium, and there's two bottom numbers, so 2 is here. The particle that's here has got to be 0 on the bottom, but it's got to be a 1 on the top. So the particle has, because there's 2 2's is 4, 3 plus 1 is 4, 2 plus 0 is 2. So what particle has no number of protons, yet 1 in the mass number, neutrons plus protons, and that's a neutron. So that is a neutron. A neutron has no protons and 1 in the mass number, 1 equals the number of neutrons plus protons. So therefore it's a neutron. So N with a 0 at the bottom and 1 at the top, that's a neutron. That should get you started. I will talk to you later, and good luck. Work on that accommodating project. and check